A very good morning to all the students. I am Dr. HimaBindhu, Assistant Professor in the Department of Mechanical Engineering. And I'll be dealing with robotics subject. And my today's topic is forward and inverse kinematics. Firstly, before we get into what is forward and inverse kinematics and what is the use of forward and inverse kinematics in robotics, we need to know the term right? We need to know the term kinematics. What is the use of kinematics? What is the definition of kinematics? Right? Kinematics is nothing but it is a mechanism which deals with the movement or which deals with the motion of the manipulator of the robot without any form of force, right? Kinematics in terms of robotics is nothing but it is a measure, or it is kinematics is a science which deals with the motion analysis of the robot's arm or motion analysis of the robot manipulator where there is no amount of force being considered, right? This is known as kinematics in terms of robotics, right? So we have two types of kinematics here. We'll be using two types of kinematics. One is the forward kinematics and the other is the inverse kinematics. What do we mean by a forward kinematics and what do we mean by an inverse kinematics, right? Everyone will be having a doubt. How is the movement of the robot being done, and what are the various links or joints we have with the robot, and how is the end effector movement being done? So all these purely depends upon the forward and the inverse kinematics, right? You can see the figure here, line diagram of the robot manipulator. Before we get into that, let us see what, as I've told you, what do we mean by kinematics, right? Kinematics, it is nothing but it is the study of the motion, right? Kinematics is a study of the motion without considering the cause of the motion such as force and torque, right? The same thing I've told you, right? Kinematics, it is nothing but it deals with the motion without interrupting the force and torque into it, right? That is, it is a study of the motion without considering the cause of motion such as force and torque, right? That is known as kinematics. So here in kinematics, as I've told you, we have two types of kinematics: forward kinematics and inverse kinematics. So what do we mean by forward kinematics? Right? It is nothing but it refers to the process which is obtaining the position and velocity of the end effectors. Right? The forward kinematics refers to the velocity of the end effectors with the help of joint angles and angular velocity, right? With the help of the joint angles and angular velocity, the velocity of the end effectors will be obtained. That is known as the forward kinematics. Right? For example, if a shoulder and elbow joint angles are given for arm in a plane, the goal is to find the Cartesian coordinate of the wrist. For example, that is, as I've told you, this is the forward kinematics, right? So here, this is the base of the robo. Here, this is one of the joint, L1. This is the other joint, L2. This is the third joint, L3. This is the fourth joint, L2. At the end, we have the end effector, right? So, in the forward kinematics, what we deal with, right? In the forward kinematics, what we deal with. Here, initially, we'll be having a fixed base, right? The base will be fixed, and to this particular base we have several joints being placed, right? To this particular base we have several joints being placed. right? So this particular initially in a static condition, when the robot is in a static condition, initially when the robot is in a static condition, in that particular time, the base and the end effectors or the links all will be in the constant position without any movement in the joints of the robo, right? That is, all the coordinate systems will be in a static condition without any form of movement. Whereas as the robot movement is being started, as there is any particular motion movement being started within the robo, in that particular case, all the Cartesian coordinate systems or the frames of the robo position or the position of the robo will be changed. Right? Initially, when it is in the static condition, all the base as well as the coordinates will be in a static condition, or it will be in a constant condition. As the robo movement is being done, as the robo starts moving, as the robo movement is being done, in that particular case, there will be the change in the position, or there will be the change in the coordinate systems, right? There will be change in the coordinate systems. So that particular change in the coordinate system will be done with the help of the movement of the joints or movement of the end effector. Right? That particular change in the coordinate system will be done with the help of the movement of the joints or the movement of the coordinate system. So as I've told you, here this is the base. From the base to the joint one, it is L1. The length is L1, right? And again, from L1 to L1 to L2, the length is L2. This for the second joint, and for the third joint, the length is considered as L3. For the fourth joint, the length is considered as L4. That is, in the forward kinematics, if L1 in the forward kinematics, if we know L1, L2, L3, L4, we can find out the end effector movement position, or we can tell the position. If we are knowing the lengths of the joints, or if we are knowing the movement of the joints, we can find out the end effector position or orientation. Right? That is known as the forward kinematics. Whereas in the reverse kinematics, with the help of the end effector movement, right? With the help of the end effector movement, that is, first we will be finding out end effector movement, based on which we will be finding all these particular joints, right? Based on this, we will be finding all these particular joints, right? That is known as the inverse kinematics, right? That is known as the inverse kinematics. That is reverse of the forward kinematics. In forward kinematics, what we are doing? Initially, with the help of the joint angles, that is Q1, Q2, Q3, Q4, or with the help of the displacements of the joints L1, L2, L3, L4, we will be finding out the end effector position, that is XY, right? Whereas in the inverse kinematics, with the help of the end effector position, that is XY, we will be finding out the joint angles Q1, Q2 and Q3. Right? It is reverse of the forward kinematics. Right? So the inverse kinematic, that is the example which was given in the forward kinematics. That is, if the shoulder and the elbow joint angles are known, we can find out the Cartesian coordinates of the wrist, that is the end effector, right? That is, if we are knowing the shoulder and elbow joint angles, we can find out the find Cartesian coordinates of the end effectors. Whereas in the inverse kinematics, what is happening? It is the use of kinematic equation to determine the motion of the robot to reach a desired position. That is, with the help of the angle of the end effector, we will be finding out the shoulder and the elbow angles. That is known as the inverse kinematics. It is when the robo is in the static condition, as I've told you, the base and the tool coordinate system will not move. Right? Just now I've explained you about that. When the robo is in the static condition, the base and the tool coordinate system will not move. Once the robo movement, that is, once there is a movement in the robo being done, in that particular position, the coordinate systems or the frame changes. Once the robo moves, the coordinate system or the position of the robo will be changing. Clear? That is, the position and orientation of each robo part are being changed as the robot movement is done. As the robot movement is done, the position and orientation of the robo will be changing. That is, as the movement of the robo is being done, there will be the changes. There will be the movement occurring in the position or orientation of the robo. So, the forward and inverse kinematics is the method to calculate the coordinates of the end effectors and the joint angle. Clear? The forward and the inverse kinematics is used to calculate the coordinates of the end effectors and the joint angle. That is, with the help of the forward kinematics, we will be finding out the end effector position. With the help of the inverse kinematics, we will be finding out the joint angles, right? That is, in the forward kinematics, with the help of the joint angles, we will be finding out the end effector angle. Whereas in the inverse kinematics, with the help of the end effector angle, we will be finding out the joint angles, vice versa. So that is known as the forward and the inverse kinematics. As you can see in this figure, in forward kinematics, what is happening? As the joint angles have been known, we will be finding out the position of the end effector. Whereas in the inverse kinematics, with the help of the end effector position, we will be finding out the joint angles. We will be finding out the angle of the joint. So this is known as the forward kinematics and inverse kinematics. Clear? So initially, when the robo is in the static condition, all the coordinate system also will be in the static condition. But as there is a movement in the robo being done, the position and orientation of the robo also gradually changes. Right. So next, moving on to the joint coordinates and world coordinates. What do we mean by the word joint coordinates, or what do we mean by the world coordinates? Right. Joint coordinates or the world coordinates are one of the very important concepts in robotics. Right. Generally, these particular type of the coordinate system are used in computer graphics, particularly when dealing with articulated system like robotic arm or animations. Right. So generally, the joint coordinate systems or the world coordinate systems are being used in the. It is one of the essential concept, we can also tell as one of the essential concept in robotics, because it is used in computer graphics, it is used in the animation, or it is used to articulate the robotic arms. So what exactly is a joint coordinate? What is the use of this particular joint coordinate? That is, when any particular robot arm or the joint coordinates are being taken, the angles of each of the joint will be relative to the reference position, right? That is, when we are considering any particular type of the robot arm or any particular type of the joint coordinates, that particular coordinates or that particular arm will include some of the angle, as we have seen earlier. From base to the joint, here we are having one angle Q1. Again, from joint 1 to joint 2, we are having some angle Q2, right? So these particular joints are called as joint coordinates. These particular joints, which are including some of the angles with reference to the joint, are known as the joint coordinate, which are relative to the predefined position. Right, relative to the predefined position, where it is taking some radius, where it is taking some particular degree of movement. So that is known as the joint coordinate. That is, a joint coordinate refers to the positional information. Right? The joint coordinates generally refers to the position information of the individual joints, or it refers to the position of the joint from one joint to the other, right, or from the one joint to the other. It refers to the position of the individual joints or any particular type of articulated points within which the mechanical systems such as robot manipulator are being included. That is known as the joint coordinate system. Right? Whereas the joint coordinates are typically expressed in terms of joint angles, as we have seen Q1, Q2, Q3, all these are called as joint coordinates or joint displacement. Joint displacement means what? We have taken no L1, L2, L3. So these are called as joint displacements, right? Or other joint specific parameters depend upon revolutionary or prismatic point that we will be seeing in the next slide. Right, so this is known as the joint coordinate system. That is, when we are considering any particular robot's manipulator, we will be having some certain joints, right? We will be having some certain joints. So these particular joints referred to the robot manipulator is known as the joint coordinate, or any particular displacement like L1, L2 from one joint to the other joint is known as the robot coordinate system. So this generally typically depends upon the revolutionary or prismatic run, that is the movement of the motion, depending upon the movement of the robot, whether it is done in revolutionary movement or whether it is done in the prismatic movement. Depending upon the movement, we define the joint coordinate. Clear? So these are generally used in animations, robotic arms, computer graphics. So these are some of the applications of the joint coordinate systems. Right? Next, moving on to the term world coordinate system. What do we mean by the term world coordinate system? That is, when we have any particular type of three-dimensional environment, or when we have any particular type of the world coordinates, right? This defines the position of the object. Right? The world coordinate system defines the position of the object around its circumferences. Right? It defines the position where that particular object is being placed on a three-dimensional environment. Where is that particular object being placed? That will be determined with the help of the world coordinate system, or any particular type of obstacles being occurred on the surroundings, or any particular targets relative to the fixed origin, or any particular type of navigation or manipulation within these scenes. All that particular applications come under the term world coordinate systems. So here in the world coordinate system, what are we doing? World means what? It is nothing but our surrounding, right? So within our particular global coordinate system, the position of any particular object, or the position or the orientation of any particular object will be determined with the help of the world coordinate system. That is, the world coordinates also, it is known as the global coordinate. Right, the world coordinates is also known as the global coordinates, which represent the position on its surrounding frame that encompasses the entire environment. Right, so this can be taken in different angles. It can be taken x, y, and z coordinates system. Right, it can be taken in different coordinate system, that is with the coordinates of x, y, and z, or we can take 0 0 0 when it is at a constant position. It is the origin, that is at its origin we are considering, right? That is, the world coordinate is usually defined relative to a fixed point in the space, Often the origin will be 0, 0, 0 with axis aligned according to the predefined convention, that is right hand rule. So that is known as the world coordinate system. Generally here the objects on the or the points within the scene are described in terms of the position and orientation, as I have told you. Generally, it is on any particular global environment. In order to find out the position or orientation of any object, we will be finding out with the help of the world coordinate system at a constant origin 0, 0, 0 if we are taking a three-dimensional plane. If you are taking a two-dimensional plane, it will be x and y, that is 0 and 0 orientation, origin, right? So, what are the applications of this? It is used to find out the position of the object. It is used to find out the obstacles being occurred on the object, or any particular target fixed origin it has, or any sort of navigation or manipulation has been taking place around its surrounding, will be found by the world coordinate system. Clear? Next, here in the forward and inverse kinematics, we use these particular terms in various forms. That is, the relationship between the joint coordinates and the world coordinates was being established with the help of the kinematic equation. Right? The relation between the joint coordinates and the world coordinates was being established with the help of the kinematic equation or with the help of a transformation matrices. So the joint coordinates for forward kinematics determine the position and orientation of the end effector. For forward kinematics, we determine the position and orientation of the end effectors, whereas for the inverse kinematics, we calculate the joint coordinates necessary to achieve the position and orientation in the world coordinate systems. Clear? For the forward kinematics, we determine position and orientation of end effector. Whereas in the inverse kinematics, with the help of the end effector, we will be finding out the joint coordinate system in terms of world coordinates. Right? So this mapping between the joint and world coordinates enables the robotic system to perform tasks such as path planning, object manipulation, and motion control. The joint and world coordinate system are used to do a path planning, the object manipulation, and the motion control of the robot. Clear? So, a better understanding of this particular distinguish between the joint coordinates and world coordinates is crucial for effectively controlling the programming robotic system. In order to control any particular type of the robot's program, we need to know about the joint coordinates and the world coordinates systems. Right? And as I've told you, computer graphics is one of the main application of this particular world coordinate and the joint coordinate system. Clear? Next, moving on to the manipulator kinematics. What do we mean by manipulator kinematics? Yes. What do we mean by manipulator kinematics? How is this particular manipulator kinematics have come into account? Yes. Here, the manipulator kinematics is nothing but it is a geometrical problem which has been occurred to compute the position and orientation of the robot. Right? It is the geometrical problem which has been occurred in order to find out the position and orientation of the robot end effector with the help of the joint angles. So here we have below we have a few of the case studies being formed. That is, when we are attaching an inertial frame to the robot base, how it is being studied. When the attachment of frame to the links include the end effector, how it is being done. How we determine the homogeneous transformation between each frame, it's been found out. Applying the set of the transforms sequentially to obtain a final overall transformation, how it is being done. So generally all this particular type of the robot manipulators was been introduced with the help of a scientist called Dinavit and Hattenberg. Right? The robot manipulator was being first introduced with a scientist called as the Dinavit and Hattenberg in 1955. Right? In the year 1955, Dinavit and Hattenberg have introduced this particular manipulator kinematics. So there we have various sort of robot manipulator kinematics depending upon the various configurations, right? Depending upon the various manipulator systems, we had various sort. So here, when if we can see, this is a revolutionary type of the robot joint. What do we mean by revolutionary type? Here we have only one link to the upper and the lower frame. Here we have only one link. So the frame here can only rotate, right? The frame here, the upper frame here with respect to the lower frame, with respect to the joint can only rotate. So it is called as a revolutionary It is called as a revolutionary joint. Whereas when you come to a prismatic joint, what is happening here in prismatic joint? Here, to this particular cylinder, we have an invert being placed, where to this the robot ring is being placed. So here it can rotate. This particular ring can have a rotational motion as well as the vertical motion. That is, it can rotate and it can also move up and down. So that is known as a prismatic coordinate system. Whereas in the cylindrical, what is happening? Here also it can rotate as well as it can move in up and down form. That is, it can move in a vertical direction. Whereas in the screw system, what is happening? Here all the cylinder is with the help of the threadings. So this particular here we cannot have the vertical motion as that of the cylindrical and prismatic, whereas it will be moving from one thread to the other thread, right? Whereas this particular ring of the robo can be moving from one thread to the other thread. Whereas in the planar motion, what is happening? We can just identify the orientation of the robo, right? We can just identify the orientation or position of the robo. That is known as a planar coordinate system or planar robotic manipulator system. Whereas in the spherical also, here we can just identify the position of the particular robot manipulator. Right? So these are different types of the robot manipulator in terms of chain or rigid link attachment with respect to the series of joint. Okay. So as I've told you, the revolutionary joints are comprised of single fixed axis of rotation. That is, it consists of only single fixed axis. This is the single fixed axis and it has only rotational motion. Whereas in the prismatic joint, what is happening? It consists of a single linear axis of the movement. Right? In the prismatic joint, what is happening? We have a single linear axis of the movement, whereas in the cylindrical joint consists of 2 degrees of movement which revolute around an axis and linear along the axis, as I've told you. And in the planar joint comprises of 2 degrees of movement, both linear, lying in a fixed plane, which is having only one particular fixed plane. Whereas in the spherical joint comprises of 2 degrees of freedom, both revolute around a fixed joint of the part. Whereas in the screw joint, what happens? It consists of the single degree of movement, combining rotation and linear displacement in the fixed ratio. However, the last four joints configure can be modeled as a degeneration concentration of the fixed two basic joints. That is, here these are the different types of the robot manipulators which we will be having in the robot. Clear? So this is all for today. In today's class, we have seen about what is the use of kinematic. What is kinematics, and what do we mean by forward kinematics, and what do we mean by inverse kinematics, and what is the use of the forward and inverse kinematics, and what are the different types of robot manipulators, and how they will be working. What is joint coordinate system, and what is the term world coordinate system? All that we have studied in today's class. Hope you have understood. Signing off for today, Dr. G. HimaBindhu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.